Okay, be reminded, you are now being recorded. So let's go to this three-moment equation. Again, this method in determining indeterminate structures uses the flexible category principle. This gives the relation between the internal moments in a continuous beam at 3 points of supports to the loads acting between the supports, meaning to say continuous. Magsiningali kita continuous, hindi lang siya isa ka span, kundi 2 or more ang aton nga beam, which is practically amo gid man ayang setup in real world. Kung nagtanaw nyo bala ang mga buildings ta, hindi lang manasing buildings ta, isa lang yaya ka beam. Di bala, damo na siya sang mga support in between. So we call that continuous beam. So this three-moment equation method was developed by French engineer Clapeyron in 1857. This is widely used in finding the reactions in a continuous beam. The three-moment equation uses the unknown bending moments, the supports, as unknowns, and two consecutive spans of the continuous beam are considered at one time, meaning to say, if we are going to use this three-moment equation method, we can only analyze two adjacent beams at the same time. So, hindi siya pwede ma-analyze nga dulungan ang 3 ka beam, ang 4 ka beam, hindi pwede. 2 spans at a time or depende. If we have a prop beam. So a prop beam can be analyzed na using the three-moment equation. So when we say prop beam, at least may ara kita nga 4 reactions. So prop beams are considered to be indeterminate beam. So, paano na siya? Pwede tabala i-apply ang three-moment equation sa kay prop beam, kay isa lang na siya kaspan? Pwede gid. So, you will know later kung nga pwede. Another is that the three-moment equation is that the compatibility equations is written in terms of three moments, known as the equations of three moments. So from the name of the method itself, the three-moment equation, we will be utilizing the values or the moment nga variable to be our unknown in terms of the moments. 3 ka moment ang aton nga i-consider sa isa ka equation. And each span is treated individually as a simply supported beam with external loads and two end support moments. And for each individual support, one compatibility equation is written in terms of three moments. And in each equation, we'll only have 3 unknowns. So we need to express, di ba, when our lessons on algebra, the learnings that we have is that if we have 3 unknowns, we at least should have 3 equations also in order for us to determine our unknowns. Pero kung kulang imo equation, then you would not be able to compute for the unknowns. Dapat ga-correspond siya as to the number of known. So in this equation here, you will be having 3 unknowns. So let's go to the derivation of the 3-moment equation. Paano tani na-derive? Example, if we have here a continuous beam wherein it is with varying loads, combination of a varying loads and a concentrated loads. Let's name it as our A, B, and C. ang aton nga mga support. So in order to have consistent labels or subscript to be used in our equation, let's label this as point A here is the support from the left of B. So meaning to say, our B here is the center. And then, ang sa iya nga point C, that will be our right support. So let's express the three-moment equation in terms of this: the left, the right, and the center. Regardless of the labels that we have for each point here, you have to understand the principle kung diin na siya, kung left na siya bala, kung center na siya, o kung right. Okay? Next, the formulation applied is based on the conjugate beam method. So when we talk about conjugate beam, we compute for the shear and moment values sang aton nga given beam. And then once we already have the shear and moment values, we apply the boundary conditions sa iya nga mga supports. We change it. So let's say the left side here, the center, and the right side is our, this here is our real beam, and at the bottom here is our conjugate beam. So the boundary conditions for the conjugate beam, kung interior roller gani kuno siya, kay continue siya mo. So kung continue siya, di ba, ang sa tunga yan na may mga support siya. So ang condition, boundary conditions ni conjugate beam, if there are presence of roller in between the spans of our beam, then you are going to treat that as internal hinge sa aton nga conjugate beam. So in this case here, sa aton nga real beam, there are presence of rollers. So paano ta na siya karon kung na-draw ta na ang shear and moment diagram niya sang aton nga real beam, drawing ta na ang iya nga conjugate beam. But the condition would be from roller, it would become a hinge. So since there are 3 rollers, then there will be 3 hinges also in our conjugate beam. Then there you are, that is our diagram, the shear and moment diagram. Ang equivalent sa aton nga real beam, this is our conjugate beam. So ang siling ni conjugate beam, kung positive gani ang iya nga moment, then you are going to treat it as your positive load. It will be drawn above the neutral axis of our beam. So, ang arrow, the direction of the arrow would be upward. So, muna ni siya, upward siya, ang aton nga stresses. And this M over EI diagram here, this moment diagram here, is actually the area. The area sang aton nga load. Then after that, you are going to locate the centroid of the M over EI diagram. Pangitaon nyo iya centroid, kundi inabala na fall ang iya nga centroid based on a specific reference. Ara na siya. So this means here, sa left sang aton nga point B, kamuni ang aton nga span. So the span has this area, and the centroid is reference sa point sang aton nga left support. And ang aton nga right area here, which is our M over EI diagram, is reference sa aton nga right support. That is the centroid. And at the center, of course, we have the shear values. Makompute aton nga shear values. And so with the support at the left and right. We are going to apply now the principle of superposition to draw the M over EI diagram. So ang principle ni superposition, the value of the moment at the left support is equal to the shear times its span, the shear times its span. That is the left to center support. And that is our moment. You're going to reflect it as your moment at the left support over EI. Dapat may EI kay M over EI diagram ang aton nga gindraw. Next, how about the moment value at the center? Again, class, si linear 3-moment equation, you are going to consider each span as a simply supported beam. So, kung simply supported beam here, amo ning aton nga value sang moment. Now, for this left to center nga span, simply supported na siya kuno. And the reaction of that would be the shear values. So, the moment value naman sa aton nga center span to the left lang sang aton nga B is given by the reaction here times the span would give you moment at the center. Amo na siya ang sa left span. How about sa right span? So, sa right span naman, we have the moment just to the right of B here. The moment value of that would be moment sa C over EI. Then, ang moment na naman sa right side is moment sa right, that is this shear here times the distance would give you this. So, class, don't be confused. Don't get confused. We have point C here and we have C here. Lain na siya, class, ha. Amo na gani nga, dapat i-familiarize ta nga ang labeling ta is that we have the left, the center, and the right. So, MC here represents moment at the center. Kaya kung mag-change na kita karon sa span, we are going to analyze na ang adjacent side sini, ang adjacent sang aton nga beam. Example, kung continuous beam ni, may kasugpon pa ni gari mga 3 ka beam. So, you are going to move or you're going to use naman another combination sang aton nga span. Ang gamiton nyo naman na C to D kag D to E. Now, if you're going to use moment at C, ma-confuse kita. We will just use moment sang center, so right and left. So, kung ma-identify ta na later, pwede ta na siya ibase sa aton nga mga points. Okay, next. When we have this load here, of course, may deflection kita. And most likely, the configuration of our deformation here would look something like this. Padalom siya ang aton nga deformation. And dili naman niya sa support as if there is continuity of the slope. So, since the slope of the beam, real beam, is continuous over the center support, the shear forces for the conjugate beam is given by this equation. Okay, next. So the equation, the shear force for the conjugate beam is given by this, the shear at the left support plus the shear of the second support, L sub 1 and L sub 2, minus the shear at the right support, so first, and we have the shear at the shear number 2. If you're going to, let's say that is your equation 1. The shear values here is equal to the shear values at the left, at the right. So the conjugate beam due to the external loads is given by this figure, and the conjugate beam due to end moment is given by this figure na. So gin-transpose na lang. So with that, kagay na to nga drawing ta, let's say, tabunan ta siya anay. Para hindi maglibog ulo nyo. Kaya nagapamangkot na siya nga ang daw kabudalom haw. Nagapampuay na siya kag nagagwa ng question mark sa iya. So tabunan ta na lang siya anay. Para ma-focus ka mo diri sa isa ka figure lang. So let's see, what is that? Consider the left span. Ari aton nga left span. Take moment at A. Ari aton ni, take moment at A. So the shear, sa first figure ta, shear due to the external load plus the shear due to the end moments to our conjugate beam here, multiplied by the distance, the span of the left. So L here corresponds to the left span. The left span siya. So this equation is equal to A times L over EI sang left span. Tanan nga mga terms, L na ang iya nga subscript because we are referring to the left span sang aton nga two span nga gina-consider. Times the centroid. So, ang centroid, that is X over L. Plus, 1/2 area sang triangle, ML over EI times ang iya nga length, smaller triangle. This one. So, ang area sini is given by 1/2 sang ML over EIL over the span sang left. So, area sining triangle. Amo ni nga aton nga area. But plus pagid. May isa pagid ka area. Area sang dako nga triangle. So, ang area sang triangle, MC sang center, moment sa center, over EI times the span man nga length. Of course, ang iya nga centroid from A. Kay nagkuha kita sang moment at A. So, you are rotating all the areas with reference to point A or around A. Now, let's check. The shear values times the length, shear values niya times the length is equal to the sum of all the area times the centroid of our figures here. Tatlo, isa, duha, tatlo. That's why we have this expression. So, simplifying, we have shear, the left side of the due to load, plus ang shear to the second figure here is equal to these values na. We simplify this. So this will be our equation 2. So we have two equations na out of this figure. Next, if you're going to substitute 2 and 3 in equation 1, amo ni nga equation 1 kagaina, kung i-substitute itong mga values na computa kay 2 and 3, we have this expression. Transposing terms without moment in it. Anong transposing terms without moment in it? Because when we say 3-moment equation, we are dealing with moments. The equation. So, iniwala siya sang moment. Iniwala man siya sang moment. So, i-transpose ta sila diri sa left side sang equation. Ang kutob may mga moment, isaylo ta sila sa left. So, this is now what we call our 3-moment equation. Amo ni atong 3-moment equation. See, the moment at the left side times its span over the moment of inertia plus twice the moment at the center times the sum of two lengths. The sum of two lengths plus the moment at the right times the span at the right. So this is equal to the summation of all forces AL times XL over I times L. Okay? If the supports are on the same level, so kung pariho kuno ang imo nga support at one level lang, then the equation for your moment would be that the moment of inertia at L here and IR here is equal to 1. We could say that our moment equation to be used is this one. Basta the same level lang ha. Basta the same level, we have this 3-moment equation. Okay? Hapos naman sa ulo ang 3-moment equation ha. Sa left, kagang iyang span. Sa center, twice siya. Sa center. Tapos, i-add mo ang tanan nga span. Then, sa right niya, multiplied mo sang center man. Length man sang last. Next naman, tabunan ta naman sa piyak. Consider the right span. So, kung si right span naman, we take moment at C. We derive in the same equation. Pero, lain lang niya ang iyang mga subscript because we are considering the right portion of the beam. So, instead of L, puros na siya mga right. Okay? Amo na nga aton nga 3-moment equation. So, substituting 2 and 3 again. In equation 1, we derive in our 3-moment equation for the right beam. Sa right naman sa right span sa ating beam. We derive in the moment equation. Okay, so do medyo malawig-lawig nga sa uluhon nga formula. Pero dapat kung sa ulo ka mo, left, twice sa right, tapos plus naman sa right. At twice gali sa center, then sa right. How about, dari amo to siya if gamiton ta kung wala sang settlement. How about kung may settlement sa aton nga beam o nag-us-us ang duha ka support? or ang isa ka support, nag-settle siya, padalong. So what equations are we going to use here? Your support A here has dropped down to the height of H1. Tapos, ang imong H2, may ara man siya yaya, nag-down man siya. Then, what formula are we going to use here? We have to use equals 6EI, H of 1 over span sang left plus H of 2 over span sang R here. Pero kung the same level yaya, equal 0. Pero kung hindi siya gani yaya nga the same level, then amo ni equal sa 6EI. Kay may settlement siya. Okay, try to copy the formulas. Now, the values nga summation of 6 times the area sang left times ang distance ang centroid sang left span over the left span. Ang ini siya, these are factors. Okay, next. How to compute the values of the factors? Ari class, in case na may mga formulas ng ibang class, you could go over sa textbook or pwede nyo gid na siya yung computon ang factors. Because when we say 3-moment equation, kailangan tagid ang values ang factors. So, for uniform loads on a span, kung uniform load ang span, assuming may W siya nga span, given L ang iya nga span. You're going to compute the reaction. You can draw the M over EI diagram. Paano ni siya? WL over 2 times the span will give you the value sa moment sa aton nga factor sa AB to be equal to WL squared over 2. WL over 2 times L, ang maniga niya. That is, for the reaction WL over 2 pa lang na. How about ang uniformly distributed na W? So, we have W, L times L over 2 is given by WL squared over 2. Amo nang aton nga M over DEI diagram for internal moment. Then you have to compute for the centroids from either point A or point B. And then take the moment of areas from A. O take the moment of the areas. Pag silingan ni take the moment of the areas, get the area of the M over EI diagram here times its centroid from A. Ang mga may arak ta di sang aton equation. Same true with the second degree curve. We have this equation. Simplifying, we say that the factor 6 to the left, factor to the left, sa left kita kaya ginalize na sa left. Factor to the left because we made point A here as our reference. So, factor to the left is equal to W cubed over 4. Amo ng formula kung uniformly distributed siya. Again, that is only the factor. Hindi na siya ang 3-moment equation. That factor will be substituted dito sa aton nga 3-moment equation. Any question? Class, may pamangkot? Pumati ka mo, pero kung maintindihan nyo ni si concept ng 3-moment equation, of all the, masapos di siya kaysa method of consistent deformation, which I uploaded na dito sa inyong nga classroom. Basta 63 moment equation computon. Basta mabalaan nyo lang mag-compute sa inyong factor. Now, for the triangular loads naman, what is the value of your factor here? If you are analyzing the left. Basta gani factor gang may mga LL niyo, that is to the left. Kung may R naman na siya, ang right span naman ang inyong gina-analyze. So, for triangular loads on the span, get the reaction. The M over EI diagram would be this one. Okay, next. Same, kwaon ng centroid. Ay, sorry class. Kwaon niyo magyapon ang iyang centroid. Pag makuha ang centroid, of course, compute nyo man ang mga reactions. So, you can, after knowing that, you can now compute for the value of the factors. Ang factors ta, based on the formula kagaina, we have 6ax over L times. Ipagwa tang 6 kagang L kay common factor sa duha ka term. So, we have WL squared over 6, the area, times L over 2, the area, dinato WL cube over 6, times L over 2, two-thirds of L. We also have here WL squared minus sa dalom, WL squared times L over 4 times 4/5 times an L. So, simplifying that, we have our factor equals 8 over 60 WL cube. Sa left niya, factor niya sang left. So, in short, if maka-encounter ka mo sa amo ni klaseng load, triangular load, wherein ang iyang vertex niya is ari sa point A, then it is ascending. Kaya may araman kay siya nga descending mo. So, if this is ascending, then you use this 8 over 60 WL cube. Kaya kung balis ka di siya, kung ari di siya ang imong W, padalom, then it would be 7 over 60 WL cube. So, this is another formula for the factors. For the value of to the right naman, sang factor, sang aton we have this 7 over 60. Amo ni sili ko kay na 7 over 60, ang isa to 8 over 60. Depende na kung di ang location sang inyong point of vertex. Then we have this connected load on the span. Ano naman ni ang iyaya na factor? We are showing you how to compute the factors, class, ha? Okay, next. Compute for the reactions. Then, draw the shear end moment diagram using, ano to gani class ang ato natunan last time? Cantilever and method or bending moment by part. So, i-apply ta na siya di. Paano mag-draw sang iya bending moment diagram? We have P. P times B, amo ng aton moment. Here, reaction 1 times L, amo naman ng aton nga moment values. Then, compute for the centroid. Once ma-compute nyo ng centroid, take moment of areas from A. Okay, if you're computing for the left factor, moment area from A, we have this values. Kung dili kita, basta gani magsilingan nga factor for A here, you take moment at A. Kaya ang left side na gina-consider ta, ang diri siya. With reference to A. So the formula that you're going to use here for this loading condition, amo ni ang iya, PA times L squared minus A squared over L. O paano kung sa left naman niya? Kung sa right naman, ang kwaon mga factor, amo naman yung right, nga value. Diri ka kuha sa point B. Take moment ka sa point B. Kagaya na to, sa left sila, kaya ang factor sa left ang ginapangita mo. Ti subong niya, kung factor sa right naman ang ginapangita mo, ari ka di, point B ang imo nga take moment. That is the factor that you're going to use for the right. Okay, next. Kung in case malipatan yung formula ni class, then the concept is that you draw the shear and moment diagram, then you can use bending moment by parts para makompute nyo ang moment values. Bending moment by parts using the cantilever method sa pag-compute sa aton nga moment. So this is now the summary of formulas for the factors that you are going to use. If you are analyzing the right portion, then we have this formula. The right section, amo naman ni. So for this type of loading condition, ang value ko na ang isang factor is given by this expression. Ang sa right naman, this is given by this. For the uniformly distributed load, we have WL cube over 4. Pariho. Kahit di ka uniformly distributed sila mo. So we have this WL cube over 4. For triangular load, now take note. Sa point A, iya vertex. Sa point B, RD iya nga W. Ano na yung values. Try to copy class the formulas of the given regular loads. Are you done taking screenshot?
Yes, ma'am.
Okay, very good. I'm going to take generate anay ko attendance sa langid. Kaysa kayo mag-generate attendance automatic, makita na karon kung ano oras nga ara ka mo. Okay, try to copy because that's very important when we use now the three-moment equation. Another loading condition here. Try to copy the formulas or take a screenshot. Again, paano ni siya nakuha? Sa concept nga to, you consider the left span, and then, draw the M over EI diagram sa amunang left span. Kung sa right span naman, paano makuha ang factor? Same naman, you draw the M over EI diagram. Ang relationship ni conjugate beam kag ni real beam. So, it would give you this expression here. Mga ready na nga equation. So,
Hey,
let's...
ma'am.
Yes.
Ay, wala na lang, ma'am.
Yes, Clyde. I will just stop recording class para hindi matama ka kalawig.